students, this is Reema. So today in this video I'll be taking the new chapter of class 9 physics. The name of the chapter is motion. Okay, so this is a very important chapter because this is actually a base chapter. Okay, so in your 11th and 12th you will be in the mechanics, you will be learning a lot more about the motions. So pay attention and make all the basic concepts very clear so that it will be very easy when you go on deeper into the motion chapter. Okay, so let's get started. So the name of the chapter is motion. Okay, you know what is motion, right? Motion means what? Movement. Okay, so before going on to our motion chapter, let's see some basic terms. Okay, so that when going on deeper into this chapter, you will not get confused when I use those terms. Okay, so the first thing is physical quantities. Okay, so what are physical quantities? So what are physical quantities? Physical quantities are all the things that you can measure. That is, in physics, basically whatever things you can measure, we call it as a physical quantity. For example, what? The weight of a person, the length of a road, the speed of a car. Other examples are what? The radius of a circle. These all are physical quantities. You know that, right? The physical quantities. What are the examples? Examples are length, speed, weight, area, radius, distance. These all are called, in physics, these all are known as physical quantities. And now we classify physical quantities into two things, that is scalar and vector quantities. Okay, so our chapter name is motion, and in this chapter we will come across certain physical quantities. Okay, so those physical quantities are categorized into two. Okay, that is scalar quantities and vector quantities. So first thing we will study what is a scalar quantity. Okay, scalar quantities are very simple. Okay, the quantities having only magnitude and no direction. Okay, when we measure time. Okay, when we measure time, what we'll say? It is 10 o'clock. We will not say any direction, right? So for measuring time, we don't need any direction. We only need the magnitude. What is magnitude? Magnitude means numerical value. Okay, we only need that numerical value for measuring time. So time is a scalar quantity. For example, distance. I am saying the distance from my home to my school is 20 kilometer. So I am not saying any direction. I am just specifying the magnitude, just specifying the numerical value. So that distance is a scalar quantity which is having only magnitude, no direction, and also speed. So the main terms we have to consider in this chapter are distance and speed, because it is related to the motion, right? So the scalar quantities are quantities having only magnitude and no direction. For example, distance and speed. Okay, and now moving on to the vector quantities. Okay, vector quantities are also physical quantities having magnitude and direction. The vector quantities have both magnitude and direction. Okay, so the examples are velocity and displacement, which we will be studying in this chapter. Okay, so no need of any confusion. What is velocity? Velocity is same as speed, but speed with direction is velocity. What is velocity? Speed with direction. Okay, and what is displacement? Displacement is nothing but, what is displacement? Distance with direction. So what is scalar and vector quantities? Scalar quantities having only magnitude, no direction, and vector quantities having both magnitude and direction. So the examples are scalar quantities distance and speed, and vector quantities velocity and displacement. So scalar quantities we have distance, and vector quantity we have displacement. And what is in scalar quantity we have speed, and in the vector quantity we have velocity. Okay, clear, right? And now we can define what is a motion. Okay, so a body is said to be in motion when it changes its position with time. So a body is in motion, a body is in motion when it changes its position. So see, from this point my pen is now at rest. Okay, now I'm changing the position of the pen to here. So my pen is now in motion, right? Because my pen is changing the position. So a body is said to be in motion when it changes its position with time. So here time is very important. Why, I'll tell. Okay, so imagine, so let's take two examples. Okay, so imagine you are in a car. Okay, you are in a car, and you are going to the school. You are going to your school. Okay, and now on the way, what did you see? On the way you saw a bus stand. Okay, a bus stand, and here you can see Usha is standing. Okay, Usha is standing. Okay, and now Usha is also seeing you going in a car to the school. Okay, so when you are looking at Usha, what you'll see? You're thinking that Usha is moving. And when Usha is looking at you, what Usha is thinking? You are moving. Okay, so actually who is moving here? So for that reason, we are defining the motion with respect to the time. Okay, so imagine at 10 o'clock, okay, this car is at position A, and at 10:15 the car moved to position B. Okay, and imagine Usha at 10 o'clock at position A, and Usha at 10:15 also position A. Now who is moving? You know that Usha is not moving, because when time changed from 10 to 10:15, Usha is still at position A. And here what happened? When time changed from 10 to 10:15, you moved from A to B. So who is moving here? So you are moving. Why? A body, you have moved from position A to B with time. Okay, you have changed your position with time. So that is why time is also very important when you define a motion. So motion is what? A body is said to be in motion when it changes its position with time. Okay, now you know there are two states of motion, right? One is what? One is rest. Rest means what? When your body is not moving at all. That is rest. Okay, and now what is motion? And the next one is motion. So whenever your body is in movement, you are in motion. Whenever your body is not moving, you are at rest. That is, what is rest? Not moving. What is motion? Body is in movement. right? Okay, so now we study about distance and displacement. Now you know that distance is a scalar quantity and displacement is a vector quantity. For mentioning displacement, we have to mention the direction also, right? So what is distance? Distance means what? The total path length. Okay, so distance and path length are both same. Okay, so whenever in the questions and all you see path length, what is that? That is the distance. Okay, so distance is what? The total path length covered by a body from initial to final position. So the total distance is what? The total path length covered by a body from initial to final position. For example, you started from a position A, okay, from the point A, and you are going to your what is that, your friend's house, okay, point B, and then you are going to your what, your school C. So first you are going for, you started from A, that is your house, okay, your house, and then you went to your friend's place. Okay, you went to a shop. Okay, you went to a shop to buy a chocolate or pen or something. Okay, this is a shop. Okay, and then you went to school. Then you went to your school. Okay, school. So what is this now? What is the distance here covered here? Distance is the total path length covered by a body from initial to final position. What is the initial position? Initial position is a starting position, that is A. And what is the final position? Final position is what? School. Okay, so total length. So say this is 5 kilometer and this is 2 kilometer. What is the total distance covered by the body? So it is 5 plus 2. That is the total path length. So here distance is what? 5 plus 2, which is what? Which is 7 kilometer. Distance is the total path length covered from initial to final position. And now what about displacement? Displacement is the shortest distance between initial and final position. So here we'll take the same example. You started from your house and you went to the shop to buy chocolate, and then you went to school. Okay, so initial position is A and final position is C. So what is distance? Distance is from A to B and B to C. But what is displacement? Shortest distance between A and C, initial and final position. So the distance between A and C, which is the shortest distance. So this is, say it is 8 kilometer. Okay, so this is the displacement. We will not consider wherever you go, that is not the problem. The problem is only the initial and ending, that the final position. Okay, in between wherever you go, that is not the problem. In displacement, we only consider initial and final position. Okay, for example, I'll show like this. Okay, A, you started here, you went to your friend's place B, and then you came to school C. So now distance here is what? This is 5 and this is 2. Okay, distance here is 5 plus 2. Okay, distance 5 plus 2. And now what is displacement? Displacement from A to C. Okay, see, it is 6 kilometer. So here displacement is what? 6 kilometer. You understood, no? Shortest distance from initial and final is displacement. And the total path length covered from initial and final is distance. Okay, so one more important topic is there, that is type of motion. Okay, motion can be of many types. That is, first one is linear motion, or we'll call it as rectilinear motion. What is that? Motion along a straight line. That is, the motion along a straight line is called rectilinear or linear motion. For example, when an object is moving along a straight line, when a car is moving in a straight path, we call it as a linear motion. Or example, imagine a body or something is falling from on the top of a something is falling from the top of a building. Okay, so that will be in a straight line. So that is also example of a linear motion. Okay, and what is next one is a circulatory motion. What is circulatory motion? Motion along a circular path. If a car is moving around a circular path, this is circulatory motion. Another example is what? In a clock. Okay, in a clock you can see needles, no? In a clock the needles are moving in a circular path. That is also a circulatory motion. For the motion of a giant wheel, that is also circulatory motion. Okay, and the third one is the oscillatory motion. That is to and fro motion. To and fro motion, where have you seen? In pendulum, right? Pendulum, we can see to and fro motion. That is also known as oscillatory motion. So now we move on to the next topic, that is speed and velocity. Now you know that speed is what? A vector, a scalar quantity, and velocity is a vector quantity. Velocity direction has to be specified. Okay, so how will define speed? Speed is distance traveled by an object in unit time. That is distance by time is speed. Okay, so the SI unit will be meter per second. Other units are kilometer per hour, centimeter per second and all. So the SI unit is meter per second. So how will we, in all the time the speed will not be, speed of a body will not be uniform, right? So in that cases we will consider the average speed. Okay, so the average speed. So what will be the equation of average speed? Average speed is what is obtained by dividing the total distance traveled by total time taken. That is total distance by total time. So now onwards we will mention our distance as what? S. Okay, so distance will be S now. So S by T, and speed we will mention as what? V. So V is equal to S by T. Okay, so distance per unit time is speed. Average speed is total distance per total time. That is V is equal to S by T. This is one equation which is very important. You will have word problems related to that. We will see that later. So next topic is velocity. Velocity is what? A vector quantity. So the speed of an object moving in a certain direction, that is velocity. Okay, the speed of an object moving in certain direction, that is velocity. So it can be uniform or variable. Okay, consider if it is uniform. Then you have initial velocity of an object and also the final velocity of an object. So what is the average velocity there? If initial velocity will denote it as what? U from now onwards. Okay, and final velocity we will mention as V. Okay, so you have V and also U. So what will be the average velocity here? Average velocity is what? Average velocity is initial velocity plus final velocity by 2. That is U plus V by 2. Okay, so V average, that is average velocity is equal to U plus V by 2. Here velocity is also having the same unit. So SI is meter per second. Okay, we can mention as kilometer per hour and all. Okay.